we have here a pendulum bob of mass 50 grams. It's suspended from the ceiling of an elevator, and that elevator does all sorts of stuff. It goes up, it goes down with some various accelerations, decelerations. Let's just get a general equation for all of these cases. So just to visualize it a bit better, you have an elevator in which there is a string, but that string is attached to a bob having mass 50 grams, and it goes up and down with some sort of positive, negative, or zero accelerations. So let's just denote that by A. A could be negative. In that case, you would have a acceleration downwards or something like that, but let's just take it for now. And on this bob, let's draw all the forces that are acting on it. So the first force is the tension force, and the second force, well, there are only two forces, is the force due to gravity. So the force due to gravity is mass times the acceleration due to gravity. The mass is 50 grams, but let's convert that into SI units. So it will be 0.05 kilograms. So the mass due to gravity will be 0.05 times the acceleration due to gravity. Let's just take it to be Z. And that only these two forces, T and 0.05 G, these result in the acceleration or deceleration of this object, of this bob, with A. Let's just take some convention. Let's just take this direction to be positive. Then T lies in the positive direction. So T, 0.05 G, that lies in the negative direction. So it's negative 0.05 G. This is the sum of all the forces and the mass times acceleration on the other side. The mass is, well, 0.05. And the acceleration, right now it's in the positive direction for what we have assumed. So we'll write positive A. Solve for this a bit, and you would arrive at T to be equal to 0.05 G plus A. And that's done. Now you put in a value for A. G is fixed, it's 9.8 meters per second squared, and you will have an output for the value of tension. So let's just start with the first one. The first one says about going up with an acceleration of 1.2 meters per second squared. So A is equal to not positive negative, just positive 1.2 meters per second squared. So in the first case, you will have 0.05 G is 9.8, and then A is 1.2. When you add them together, you get 0.05 times 11. That's 0.55. And that's in newtons, since you're taking all in SI units. Second one is goes up with deceleration 1.2 meters per second squared. And this gets a little bit tricky, since going up with a deceleration just means it will go down sometime. So instead of now having a positive A, you might think that going up means a positive acceleration. Well, it doesn't, since it has already explicitly stated it's decelerating. So the acceleration in this case will be negative. So for the second case, you have a negative 1.2 meters per second squared. And if you use this, then you will get 0.05. The tension now will be equal to 0.05 times 9.8 minus 1.2, all of that in newtons. So this will be equal to 0.05 times 8.6. Well, if you figure out what 8.6 will be, that will be equal. The product of these two will be equal to 0.43 newtons. You can do that for this third part as well. It goes up with uniform velocity. And by uniform velocity, what do we mean? By uniform velocity, we mean A to be equal to 0. So then the tension is equal to 0.05 times G plus 0. And that's just 0.05 times 9.8. What is that equal to? That is equal to 0.49. Again, in newtons. And you can do the three parts by yourself. It's just calculating it.